Good morning, everyone. Your bell ringer here is here on the board. Please take a few minutes to go through that. So please pause the video, let people get through the bell ringer. Okay, so the first one is some review from what we did last chapter and the chapter before. So it's review of exponents. So remember, I like to think of it, we can move stuff from top to bottom or bottom to top here. So between the numbers, we can simplify that as a fraction, so you can take a 3 out of those, and it would give you a 7 on top, and it would give you a 15 on the bottom. And then for the x's, we move them to where the larger variable is, or larger exponent. So my larger exponent is on top there, so you move the 5 up and subtract. So it's going to be x to the 7th. And then my y's, my bigger one, is on top, so I'm moving them up. We have y to the 6th. That's your answer. Okay, down here we got a word problem that is similar to what we did yesterday. Okay, so an account with a balance of $1,000 pays 3.65% annual interest compounded daily. So that's important there. Compounded daily, that helps us figure out what equation we're going to use. How much is in the account at the end of 2 years? Okay, that's going to be our T, the 2 years. So remember, we have to write our percentages as decimals. So 3.65 is really 0.0365 as a percent. And then we're going to plug everything in. So our equation, I think we have our amount equals our principal times 1 plus rate divided by a number of times compounded per year, to the number of times compounded per year times the amount of years that it's compounded. Okay, so we're going to plug everything in. Amount that I started with is $1,000. 1 plus our rate is 0.0365, and the number of times compounded. Okay, compounded daily. How many days are in a year? 365. Okay, to the 365 times 2. All right, so plug that in your calculator, and you get $1,075.73. Okay, and remember that you should probably only round this to the hundredths place, because it's a dollar amount. Okay? So, 7.3, so that is Euler's number. Okay, take some time to write this down. And it's also natural base E. Okay, take a few minutes to write this stuff down, write the first example down, and then we'll get started here. All right, so E is an irrational number. It's kind of like pi, okay? And this is the expression that is given for E, okay? And this expression gets to the number E as n approaches infinity. So if you think about, we'll say positive infinity. If you think about infinity, that's like 0, 100, 1,000, 10,000, a million, it just goes on forever. Okay, as we plug in numbers for this, it gets closer to E. Okay, you can estimate larger values for E. And we're going to actually estimate that here in a minute. But for these first few examples, you can think of E as just a variable. All right? So if we have E squared times E to the 5th, well, what are you going to do with the exponent? Well, do we have the same base? Yes. If we're multiplying, then we add the exponent. So it'd be E to the 2 plus 5, or E to the 7th. Okay, simple as that. And then for B, okay, we got 12e to the 4th over 3e to the 3rd. Well, just like we did in the bell ringer, you simplify the numbers out front. So 12 divided by 3, that gives us a 4, and then we subtract exponents. So 4, we can move this one up, minus 3, so it's just e to the 1st, or just an e. Okay, a few more examples here with e, just one more here. what do we do when we have a power to a power? Okay, and we have a variable up in the exponent. Some of you guys saw that last chapter. He's like, oh my goodness, what do I do? Keep it up there, okay, and we're just going to treat it like normal, just like a number up in the exponent there. Okay, if we got power to a power, we distribute that power, so the 2 goes to both. So it's going to be 5 squared, which is 25. All right, and then we have e. Okay, well, we got power to a power, so you're just going to multiply there. So it's negative 3x times 2, so it's e to the negative 6x. And you can leave that as your answer. Or we could actually simplify it a little bit more. We'd have 25, and since that's a negative exponent there, we can take it e to the bottom and make it a positive 6x. Okay, that would be sufficient right there. So now we're going to estimate what e actually is. Alright, so I want you guys to copy down this chart. I'll have to sub-pause the video for you guys so you can actually start copying this all the way down. Okay, we go down to 3,000, and I'm going to add another one down there. We're just going to say we're going to put 10,000 in there. Alright, so copy that chart, and then you're going to plug in numbers to that expression up there after you copy that chart down. Alright, so my first one would look like this. Alright, so you would put that in your calculator. And putting that in your calculator, I would do it just like that. Okay, I would put a parenthesis, 1 plus 1 divided by 5. If you wanted to put that in the parenthesis, or you could press the fraction button. I think if you press the fraction button, it would look like that in your calculator. Okay, and then you have to do the little caret symbol and then to the 5th power. So that's the way it should look when you plug it into your calculator. All right, so go ahead and do that with all the numbers and see what you get all the way down. And I would write down as many decimal places as you see. Okay, so plugging those in, you should get values that look close to e when we get down there. Okay, so the first one, you get 2.48832. Second one, should get 2.6658363331. Third one, we're using 50 now. 2.691588029. Then we're going to use 100. Okay? And we're actually going to get, I'll show you where the E button is, or I'll tell you where the E button is on your calculator. That way we can actually use that. Here, okay? So you can see our decimals are kind of starting to go up here. Okay, so 500 now. 2.715568521. Now we're going to use 1,000. And then we're going to use 3,000. And then we're going to do 10,000. Okay, so do one more if you haven't done that 10,000 yet. And then you should see some kind of consistent values once you press that 2,000 one, or 10,000 one, excuse me. 2.718145927. So really, we start out here kind of 2.4, then we jump to a 2.6. Okay, now we're at 2.6 again. Okay, now we go to a 2.7, 2.7, 2.7. And it just kind of stuck there at that 2.7. Okay, if you look at your calculator now, okay, so on my calculator, if you got that TI-30X, that's the blue one, If you look at the blue second button in the top left-hand corner and you go 2 down from that, it looks like e to the x. Okay, you should see something like that. If you don't have this calculator, then you can kind of look around on your calculator that you have and see if you can find it. If you press second and then that e to the x button, this is what you get. It looks like this. We get an e to the caret. Okay, just put a 1 in there. We're just going to do e to the first power and see what you get. Should be about 2.718. Oops. 2.718281828. That is the value of e. Okay, you guys are going to have to memorize that. I'm going to make you write that up on the test. So you better memorize that. No, I'm just kidding. You don't have to do that. That'd be torture. Okay? But you guys are going to have to know what e is. Okay? You don't have to know exactly the value of it. Okay? You might want to know that. Okay? It might be on the test for like maybe a bonus question. Okay? But just know how to use e, how to calculate with e. Alright? So on to more examples. So using that button, that e to the x button, just go ahead and punch those in your calculator quick. Okay, so you would press second, e to the x, and 4. You don't have to write these down because it's pretty easy just using your calculator. E to the fourth is approximately 54.598. And I would say if it's not specified how many decimal places to go to, just go to like your third decimal place. And then e to the x, negative 0.09, gives us 0.914. Okay, using your calculator with this is pretty easy. Now, it's not always going to be easy with just using your calculator, okay? It could be a little bit more than that. Alright, so we're actually going to graph e now. So you can use your calculator to graph e. So see if you can do that right now. We're just going to use a generic XY chart, kind of like we did with the exponentials yesterday. So we can do -2, -1, 0, 1, 2, and you could continue that on if you wanted to. So go ahead and graph that in your notes. So please pause the video. So plugging in the points, we get, so e to the x, -2, -1, so we get about 0.135, 0.368. E to the 0, that's a 1, that's an easy one. Okay, e to the first power, that's at 2.718. Okay, e to the x, okay, so e squared and e cubed. So e squared is about 7.389, e cubed is about 20.09, or 0.85. Go ahead and plot those points. So it'd be about -2.1, -1.3, 0, 1. Okay, so all exponentials go through 0, 1 if there's nothing added or subtracted. And 1, 2.718. And you can kind of see that trend there. 2 and up to 7.3. So it's going to be like this. And it goes up like that. So e is just an exponential. Alright, graph should look similar to that. And remember, this is just going to kind of get really close to that line. It's never going to touch that 0. It's never going to touch y equals 0 because that's my asymptote. So state domain and range. So my domain, well, what x values is it going to cover? Okay, well, it looks like it's going to be going on that way forever. And my little arrow here says it's going on that way forever. So if I'm covering the entire graph, okay, you could say x, or you could just say your domain is all reals. Range is a little bit different because look at our y value now. Okay, are we going below that line, that y equals 0 line? No, but we are going above that line. Okay, so our range for the graph is y is greater than or equal to, oops, not equal to, okay, y is greater than 0 because it doesn't ever touch that y equals 0, so y is greater than 0. Okay? You got to look at what values your graph is going to cover. Alright, see if you can graph these two. So please pause the video and make XY charts and graph those two. Looking at the example on the left here, at 3e to the 0.25x, we got to fill out our XY chart, and you can use decimals on this again like we did with the other problems. Okay, so XY chart, and we want to use generic points. Okay, so then we should have gotten 1.8196, and the decimal places don't really matter that much as long as you get a good estimate. 0.3. Okay, you can see that if I plugged in a 0 there, that'd be e to the 0, which would make the e turn into a 1. So it'd be 3 times 1, so it's 3. That's an easy point. Okay, so then the next point, I got 1, 3.85, and 2, 4.94. So if I graph that, -2, 1.8196, so it's about there. -1, 2.336, 0, 3, 1, 3.85, 2, 4.94. So you can see it kind of starts to jump up there. So your graph is going to kind of look like this. Missed those points a little bit, that's okay. But it's going to level off down there close to 0 again. Okay? And actually I should draw my curve a little bit nicer because it is going to go through 1, or through 3. That's the important part of this. So it's going to be kind of like that. Okay, so domain and range of this one right here. Well, think about what we did yesterday with our graphs yesterday. Where is it going to level off at? Well, that applies to the range, not the domain. Domain is x values, domain of exponentials is all reals all the time. My range, where's that asymptote at? Where am I going to level off at? Okay, well, this right here, y equals 0, is going to be our asymptote that we're never going to touch. So our range is y is greater than 0. Okay, now let's look at the other one over here. I'll move this stuff off to the side. We used that already. Okay, if you want those values, I'll put them up there. So now values for this next one. Use our generic numbers. Okay, so we get 21.086 for the first one, 10.488, 5.487 for 0. Okay, so that would be, because if you plug a 0 in there, it's not just a 1 here. If you plug a 0 in there, you get a -2 in the exponent. Okay, so -2 times 0.75, that's going to change stuff for a power of e. 1, we get a 3.117, and 2, we get a 2. So that one actually makes sense because if you plug a 2 in there, then you get a 0 in that parentheses right there. So now you have e to the 0, which is a 1. A 1 plus 1 is 2. So that makes sense. So let's graph those points here. Let's see if we can get a decent curve. So -2, we're going to be way up at like 21. Kind of put a dot up there. -1, and we got 10.48. So about 10.5. 0, 5.47. About 5.5. And 1, we got 3.117. About there. 2, we got a 2. That's an easy one to graph. Okay, so if you can see that right now, let's draw our curve. Okay, it's going to be kind of up here, coming, and then we start to curve down. Let me retry that. I'm going to go from right to left. So let's go here. We're going up. Okay, and now you would think that it's going to level off at 0, like the one on the left. But you have to remember, like our exponentials that we did yesterday, the number on the back end tells us where our asymptote is. So we got a +1. So that means my asymptote is at y equals 1. So that's going to be the line that it gets close to and never touches. Okay, if you plugged in more points, so if I plugged in a 3 and a 4 and a 5, you would get 1.472, 1.223, 1.11. So you kind of see with the points, if you do more points, that it gets close to 1 and never touches. Okay, so remember yesterday I said that you can either look at the number on the back end, which is probably the easiest way in my mind to tell where your asymptote is going to be, or you can keep plugging in more points, plugging and chugging with points for XY charts. Okay, so those are those two graphs. This one on the left here, you could also think of a plus 0 if you want to know where your asymptote is, because there's nothing added on the back end. So your asymptote would just be at y equals 0. Okay, and occasionally you might have to write the equation of the asymptote. So this one, if I wrote my equation, it's y equals 0. That's this line. Equation for this one, y equals 1. That's that line that I just drew. Okay, so those are your asymptotes. So the last example here, we're using continuous compound interest. So go ahead and take a 30 seconds or so to write that down. Okay, and the A is the amount we're looking for here. Oops. P is your principal, and it's LE for monetary amounts. R is your rate, and T is your time. Okay, so if you want some extra information on that equation. All right, so looking at an example using this stuff. So we got an account here where we're investing $4,000 at 6% interest, and over time we're just going to do it for 1 year. Okay, and that equation is really easy to remember because look at the stuff on the left, or the right. Sorry, the right spells PERT, P-E-R-T. That's an easy way to remember the equation. So PERT. You got to remember that you have P times exponential to the R times T. So looking at an example here. Calculate how much money you would have after 5, 10, 20, and 40 years. All right, so I'll get you started on the first one here, and then I'll let you do the other ones. So we have amount equals P e to the RT. The principal amount that we're starting with is $4,000. Okay, and we have the exponential, Euler's number there. Our rate is 6%, so remember you have to write that as a decimal, so it's 0.06. And over time, we're doing it for 5 years for the first one. Okay, so you put that in your calculator. 4,000 e to the 0.06 times 5. And remember, if we put that in our calculator, it'd look exactly like this. So 4,000, you do second e to the x button, so it gives you e to that caret with the parentheses. So 0.06 times 5. That's what it would look like in your calculator. Okay, when you enter that number, you should get $5,399.44. So that's a pretty good deal if we invested for 5 years. Okay, we're getting almost $1,400 back out over the course of 5 years. That's a good account. All right, go ahead and see if you can get the other ones. So pause the video and see if you can get the other numbers. All right, so we should have gotten $7,288.48 for 10 years, 20 years, $13,280.46, and for 40 years you got $44,092.71. Okay, so that is a very good account. If anybody ever finds something like that, let me know. We'll start investing money and make some good money. So that's everything. Okay, we'll skip this example for now. There is your assignment.